Hey everybody, my name is JP. Today we're going to be explaining the key concepts of fire behavior, how fire grows, what affects it, and why understanding these fundamentals keeps firefighters safe. First, let's get right to the 5 fire classes or classes of fire. You have Class A, B, C, D, and K. Class A fires are your ordinary combustibles, stuff like wood, paper, and cloth. An easy way to differentiate this stuff is anything that leaves ash is a Class A fire. A Class B fire, flammable liquids, gases like gasoline, oil, or propane. Anything petroleum based. Any kind of a fluid or a petroleum that would ignite and burn is a Class B fire. Class C fires are electrical, anything electrical in nature, and energized equipment such as a drill press, or machinery that has an overheat or an overarching that could cause a fire. Fun fact with that, if you de-energize a Class C fire, you now have yourself a Class A fire. Class Ds are combustible metals, stuff as magnesium, sodium, titanium, even aluminum. You'll see this stuff sometimes in the engine blocks of cars. If you ever see those really extremely prophetic fires, when you put water on a hot metal fire, that's when you get the explosion of color and a very, very monumental experience. In Class K, your kitchen fires, K for kitchen. This is anything like cooking oils, fats, and stuff like that. With a Class K fire, you'll notice that individuals will have an extinguisher that looks a lot like an APW. It's Class K. It puts out a foamy substance to help suffocate the fire. Let's talk about how the fires grow and develop. Class A fires are typically smoldering to flaming combustion, whereas Class B fires have rapid ignition and a high heat release. Class C fires act the same as an A and B once they're de-energized. However, they're an A and B when it's energized, therefore Class C. Class D, extremely high heat release and reacts very violently with water, like I said earlier. Very violently with water. And Class K involves spawnification, where foam is needed to smother it. The fire growth process, right? You have your ignition, your heat, fuel, and oxygen combine. You have ignition, fire goes. Fire then grows, spreads to nearby fuel, where rollover can occur. It goes also to a fully developed fire, where all fuel is currently burning. Flashover. And then decay. This is when everything is really past the point of burning everything that it has, and it's starting to die down. All fire will go out eventually, even if we don't address it. Let's talk about pre-mixed versus diffusion flames. Pre-mixed flames, fuel and oxygen mixed before the ignition. Think of it like a Bunsen burner or a gas stove. These burn faster and cleaner. Whereas a diffusion flame, fuel and oxygen meet at the fuel source, like a candle or a house fire. Slower burn, more smoke, less efficient. Similarity, both release heat and light via combustion. The difference? Premixed is more controlled, whereas diffusion is less predictable with more smoke. Heat of combustion and efficiency. Heat of combustion. Total heat energy released when fuel burns completely. Combustion efficiency, rather, now that we know it, how much of that potential heat is actually released. Incomplete combustion, or poor ventilation, means you get less heat, but more smoke and carbon monoxide. More danger. Now, let's talk about the fire triangle and the tetrahedron. The triangle has 3 elements to it: heat, fuel, and oxygen. You remove one of these, the fire dies. Doesn't matter which one of the 3, you just have to remove one of the 3. The tetrahedron, on the other hand, adds the concept of chemical chain reaction to it. Both explain how fire sustains itself, the triangle for basics, and the tetrahedron just adds that next layer to get full combustion science. Dangers of smoke. Smoke contains carbon monoxide, hydrogen cyanide, and unburned hydrocarbons. Premixed flames produce less smoke but higher temperature. Diffusion flames produce a thick, toxic smoke, especially in enclosed spaces. Smoke obviously reduces visibility, increases heat, and kills more firefighters in flames. I do appreciate you guys spending time with me today. This has been a very quick overbrief of the classes of fire. Understanding fire behavior helps us anticipate how it will move, how we need to attack it safely, and how to protect the lives of our citizens. Firefighting isn't just about suppression, guys. It's science.